Oblique impact is when objects hit each other at angles. So, for example, let's say we have one ball, another ball, they're going like this, and then they hit each other right here, and then they both go off in another direction. So this is A, this is B. We have B A1, B B1, and we'll have B A2, B B2. They hit each other on this horizontal axis. So this is the line of impact. Because this is the direction that the forces are. Because if you think about it, when they hit each other, they're like this. So the force goes like that. The line of impact is along the force, and then perpendicular to it is the plane of contact. Well, force causes an acceleration, right? We remember from before, sum of the forces equals mass times acceleration. And then we know from the impulse and momentum, sum of F dt equals sum of m dv. Okay, so that force is going to produce a velocity change. So here in the x-axis, we can see that happen. We see that A starts out moving right, B starts out moving left, and then after they hit each other, A moves left, B moves right. But they still continue to go in the vertical direction along the plane of contact because there's no force in that vertical direction. The velocity in that direction does not change. So the y component of velocity will stay the same, the x component will change. So we need to treat oblique collisions as vectors. So along the plane of contact, velocity is conserved. Because there's no impact in that direction. Along the line of impact, that's where the forces are, so that is where velocity will change. So on this line, momentum is conserved. So in the y direction, then we know that v A1y equals v A2y because velocity does not change. And v B1y equals v B2y. So really we need to know what these angles are here. So if we know the angle that each one of these is going beforehand, then we can break it up into its vector components. So sometimes you will be given this angle, that's theta. Sometimes you may be given this other angle. Maybe that one's given. So you need to be able to know whether to choose sine or cosine based on whether the angle is given with the vertical or the horizontal. So for these, we'll just say use trig, sine or cosine of that initial angle. because you're not going to know the final angles. You'll have to calculate them. So in these problems, you'll be given initial velocities and initial angles. You'll need to figure out final velocities and final angles. Now in the x direction, momentum is conserved. So we have that standard momentum equation, MA/BA1 plus MB/BB1 equals MA/BA2 plus MB/BB2. So this is conservation of momentum. And then we also have the coefficient of restitution, the E equation. E equals negative BA2 minus BB2 over BA1 minus BB1. And we also remember that if E equals 0, that is a plastic collision. The objects stick together. If E equals 1, that is an elastic collision, and energy is conserved, super bouncy. If E is anything else in between, it's inelastic. The objects do bounce off of each other, but not a whole lot. However, this is just in the x direction. Because we treated the y direction, we had that velocity conserved. So we had those equations. Now here, in the x direction, it's conservation of momentum. So that means that each one of these is actually just the x component. So again, you'll need to know whether to use sine or cosine. And get x components of all of those velocities. First, we draw the diagram. So we need to be able to figure out what objects are involved, what forces are involved. Two, we assign coordinate frame. So we need to know line of impact. And plane of contact. So then three, we write equations. So in the y direction, velocity is conserved. And in the x direction, momentum is conserved. And the E equation. And then finally, solve. Usually we're solving for final velocities, magnitude and angle. Because they're now vectors.